We write down the minimum value, you have your Q1, you have your median, your Q3, and then your maximum value. Using those 5 numbers, we make a box and whisker plot. You ever heard of a box and whisker plot? We use those 5 numbers to create our box plot. The minimum, Q1, median, Q3, the maximum value. We found these for that same travel time example from earlier. It was on the previous page. If you look at that travel times, you even have your stem plot on the paper here. The minimum value is 5. The maximum value is 85, but we need to be careful because that was an outlier. Did you see that at the example right above where we did our outliers? We're using that data. The minimum was 5, the maximum was 85, but we're like, hey, that's an outlier, so we're going to come back to that in a second. Our Q1 value was 15. Your median was 22.5, and Q3 was 42.5. So we use those 5 numbers, and we put it on this graph. I already gave you a scale. I labeled the axis for you. My minimum value is at 5, so at 5, I put this little dash. Q1 is at 15. So I make a slightly bigger dash because this is what happens. I have this, what's called a whisker. That line's called a whisker. And then we start the box. This 15 is the start of the box. So this was my min. This is my Q1. My median at 22.5 is a continuation of the box. So that was my median. Q3 is at 42.5. So I complete the box down here. And then I've got my whisker on the other end. Except 85 is an outlier, and because 85 is an outlier at 85, I just put a dot out here because that represents my outlier. I look at my data, I'm like, what's the next highest number before 85? 65. So really I'm going to draw at most my upper end whisker here goes to 65. And then the 80 he was clear out, he's an outlier, so he goes down by himself. So my min, Q1, median, Q3, my max, technically, and this was our outlier. So check this out. From Q1 to Q3 is called my, it is the box. What's Q1 to Q3 though? Q3 minus Q1 is your IQR. So my interquartile range, looking at this, ranges from 15 to 42.5. I could subtract those numbers, and you'd say the middle 50% of our data has a range of, and we already did that, however many minutes of travel time to work. You try it. Here are the number of home runs that Hank Aaron hit in each of his 23 seasons. So we've got all that information. We want to calculate the 5-number summary. The information needs to be in increasing order or decreasing order. Just needs to be in order so that we can figure out your 5 values. Find if there's outliers, and then create a box plot. So we're kind of reviewing yesterday, and we're starting what we did today. Now here's another one. We got lots of calculator tricks up my sleeve here. Enter all the information in your calculator first, and then I'll show you how do we find min, Q1, median, Q3, and max really quick. Stat, edit. I arrow up, I clear out my list. to my home screen, you push stat, arrow over to calculate, stat, arrow over to calculate. See how it says calculate up here? Okay. Push enter for number 1, one variable statistics, and do it for list 1. It's magical. You ready? Look at all that. What's this? The mean. Good. That I just told you. Sum of the x's. Sum of the x's squared. S sub x, standard deviation. And sigma sub x, this is like lowercase sigma, is also a different standard deviation. We use this with samples and we use this with populations. But we're going to do that later. N stands for your count. And we go down, and you have your min, your Q1, your median, your Q3, and your max. How about this? Clear your calculator memory. Enter data in your list. Calculate your summary statistics. Sort data. Anyway, there's that information. Then you can calculate if there's outliers. Standard deviation is the last new thing for today, and then you guys should be able to finish up the last on your own. Standard deviation, in times past, I have shown you how to do it, and I'm like, it's a pain in the butt, so we do it on the calculator. However, end of the last try, I had somebody come to me, and they're like, hey, Mr. Roop, how do I do standard deviation by hand? Because they were required to do it. Standard deviation, I am going to have you guys practice with it a little more this time through, rather than just using our calculator to find it, because it's something you should know how to do. Standard deviation measures the average distance each observation. The average distance each observation is away from their mean. It's the average distance each of the observations are away from their mean. So, this example right here, they surveyed 9 students, and they asked 9 students, probably elementary kids, how many pets do you have? One student said, I have 1 pet. A student said, I have 3 pets. 3 students said, I have 4 pets, and so on. Okay? And this is the data. This is the process for finding standard deviation. The first thing we do is we find the mean. So I'm going to go like this. I'm going to take these dots and I'm going to turn them into numbers. I have a 1, I have a 3, I have 4, 4, 4, I have a 5, I have a 7, I have an 8, and I have a 9. So those are the numbers that correspond to the dots. Using those numbers, we find the average. So my first step, I find x bar equals what for all of these. So we add them all up, we divide by 9, you get 5. So the average of those numbers is 5. Step 2 says calculate each deviation. So a deviation is how far are those observations from the mean. So if I look at this first point, I'm like, well, my mean was right here. My x bar equals 5. This is my mean. So if I say how far is this point from the mean, if I'm at 1 and I'm at 5, I go 5 or 1 minus 5 and I get -4. So it's like saying this. It's the observation, so like x sub I minus the mean is like the notation for it. You take your x values, we subtract the mean, the observations minus the mean. So I say 1 minus 5 gives me a -4. And then we do it for the next one. Well, how far is this point from the mean. Here I'm at 3, here I'm at 5, so I go 3 minus 5 gives me a negative 2. And then I have 4 minus 5 gives me a negative 1. 5 minus 5 gives me 0. Because watch. Those are the deviations. If I want to find the average of those, we add them all up and we divide by 9, right? What do you get when you add all these up? Yeah, you do get 0. The sum is 0. Well, what does that tell us? 0 divided by 9, that doesn't, it's 0. Each of those are 0 away from the average distance, each of those are away from the mean is 0. No, that doesn't make sense. These add up, you get 0. So here's what we need to do. We need to now square each deviation. So I'm going to take this and I'm going to square it. So it's my x values subtracting the mean, we square them. So it's like saying negative 4 squared gives us 16. Negative 2 squared gives us 4. Negative 1 squared is 1. So this was step 1, this was step 2, this is step 3. Now we find the average squared deviation. If I take all of these and add them all up, what's the total? 52? Find the average squared deviation. We calculate the sum of the squared deviations, and then we divide by n minus 1. Why do we divide by n minus 1? It's a great question with a complicated answer. That's even what the book says. It comes later. But when you do standard deviation, we divide by n minus 1. So I take this. This is step 4. I take my 52. Divide by n minus 1. What does n stand for? The count, the number that you have, which is 9. 9 students minus 1. So 52 divided by 8 gives us 6.5. So this is my average squared deviation. And what it's specifically called, rather than saying, oh, that's our average squared deviation, really, that's referred to as the variance. That's the average squared deviation. I just want the average deviation. How far are each of these away from the mean? So lastly, number 5, we calculate the square root of the variance. Square root of 6.5 gives us 2.55. And this is my standard deviation. I'm always going to write it as SD just to shorten it up. 2.55 is your standard deviation. If I were being technically correct, I would say this is S sub x is equal to 2.55. Quite the process, huh? So why do we do this? How do we interpret this? What does this mean? Okay? This tells us each student, on average, the number of pets they have is 2.55 pets away from the mean of the class. The class had a mean of 5 pets, an average of 5 pets. It's a tough concept to get down, but let me give you this. This is kind of a fill in the blank kind of thing. If you can remember this definition or get it on a note card, you'll be good. So here I'm talking about students. So I say each student has on average 2.55 pets away from the mean number of pets in this group. Again, it takes a little bit to wrap your mind around, but each student has, on average, and this is absolutely key, on average, 2.55 pets away from the mean. So if I find the mean number of pets for that group, each of those students in that group, how many pets do they have away from the mean number of pets? 2.55. So average distance each observation is away from the mean. That's key. If I say, hey, which of these is the correct interpretation on a test, you'd want to know average distance from the mean. Average distance, each of those are from the mean. What's all the algebra for it, if you wanted to? Variance is s sub x squared. And then for standard deviation, we take the square root of that. So what do? We took our x values, subtracted the mean, we squared them, we added them all together, and then we divide by n minus 1. We're going to wrap this up kind of sort of together. And then we're going to finish off the bookwork. The bookwork is 92 through 98 even, 103, 105, 107, 108, 110. That's what we're going to finish up tonight. For those of you who are ready to work on that, have at it. The rest of you, we'll walk through this again one more time for standard deviation. And that last example in the packet, you can make parallel box plots